Good morning and good afternoon, and welcome to our conversation with Alpaslan Demir, a principal engineer at InterDigital. And this conversation is part of a report by Sense of Feeling, collaboration with RCR Wireless News on densification, why we need massive densification, and how is the RAN going to evolve to accommodate that, the increase in density, in capacity that we need to meet the demand out there for wireless connectivity. Alpaslan, thanks for being with us today.
Thank you.
So could you give us an introduction in terms of what is that InterDigital is doing specifically with respect to densification, and what you've been working on that topic?
Yeah, from InterDigital's perspective, as you know, InterDigital is a multi-front company for many research topics. One of the topics that we are heavily involved is the densification. And we do support multiple projects in the densification domain. And as a team, I'm part of the team who is looking at the next generation millimeter wave network. And there, we do look into the challenging problems in the densification and creating solutions, relevant to even when we talk about densification, we talk about the ultra-dense networks in general.
Right. So there are different ways to go about densification. So there is not just one way, and operators have to pursue many different roads to get to that point. And as I say, one way is to go to new bands. So let's first talk about what are these new bands? What is that you're mainly focusing on?
Like we describe, especially in the 5G domain, we call anything below 6 gigahertz and above 6 gigahertz. Mm-hmm. And our primary focus in my team is about 6 gigahertz. And with respect to about 6 gigahertz deployments, this is the millimeter wave, and some people say centimeter and then millimeter wave bands. But we are talking about frequencies 28 gigahertz or 39 gigahertz. We're talking about 60 gigahertz or 70 gigahertz. And the beauty of these frequencies are such that the bandwidth, available bandwidth, is becoming tremendously large. You are talking about 100 megabits per second or multiples of 100 megabits per second bandwidth to up to 2 gigahertz bandwidth, and multiple of them, especially at 70 gigahertz. And this is obviously giving you ability to increase your densification. And simply, when you look into the bandwidth, the more bandwidth you do have, more data you would be supporting. And when it comes to the millimeter wave domain, one thing we need to understand, the propagation loss, due to the propagation loss, you need to deploy nodes very closely. Maybe we are talking about like 50 meters to 100 meters to 200 meters nodes. This is automatically creating densification. And even the concept of looking into a bandwidth, when you say megabits per second per hertz, that concept of aerial densification comes in, and you even put per meter square term into that.
So, and the need to have a more dense network is, on one hand, it's a problem it's a limitation compared to the standard cellular, spectrum bands where you have much wider reach, but it's also an advantage because it reduces interference, right? So it's a trade-off there, because you can reuse spectrum more readily than you can do, for instance, in the 700 megahertz band.
Yeah, I mean, definitely. When you look into millimeter wave bands, the system, especially the antenna designs, are very highly directional. Mm-hmm. And you do need to have the highly directional antenna systems. But with the highly directional antenna systems, people think that you definitely suppress the interference. However, that's not, very accurate. Overall, you can reduce the interference. However, you still have interference issues with the very high directional beams.
Right. So you still need to manage. Interference is not going away anytime soon. You're not even there. Okay.
You still need to manage.
No. What kind of scenarios do you see this millimeter waves being used in deployment scenarios?
Deployment scenarios, you definitely can talk about indoor and even outdoor scenarios, urban environment, you definitely. Wherever you do need very high density that you can utilize the millimeter wave network. And you can, the campuses, enterprises, malls, all sorts of, locations, you can definitely favor utilizing millimeter wave applications.
Yeah. So, you mentioned 5G, and I think that we're seeing a trend towards obviously doing a lot of work for 5G, but some of the elements of 5G might become available before 5G is really deployed. So how do you see that, the expansion to other waves? What is the timeline? Do we need to wait for 5G, or can we get started ahead of that?
I mean, that's a very good question. When you look into a 5G domain, certain technologies are developed and certain prototypes are available. However, when you look into the ecosystem, you do not see commercially viable products yet. And especially in the RF domain, the radio domain, the antenna structures, how you merge the antenna with the RF chains, are not yet available, commercially available. So this is obviously delaying things. And the other aspect is that the standardization process. I mean, as we know, in the 3G and the 4G domain, even before, now the companies started looking into the standardization aspects of 5G. So is a reasonable time everybody is talking about is 2020 for commercially viable deployments in the 5G domain.
Okay, so before we get to 2020, what do you think is going to happen in terms of the densification?
The densification, I would definitely see from the perspective that there will be prototypes, there will be a ton of research, and the testing and the capability is going to come up. And as we can see in Europe, several research facilities or several places where the deployment scenarios are being entertained and the testing being done. And in the United States, we are expecting a similar aspect. And these days, we are expecting, especially the FCC, to create a ban so that in the United States, we can start deploying and testing our prototypes.
In terms of regulation and band availability, do you expect to be sort of do you expect to have bands which are sort of available worldwide or in most markets?
It's very difficult to achieve a global synchronization on these bands, and everybody knows that. Even when we are looking at the band that can be opened, maybe 28 gigahertz in the United States, you may not have the same band all over the world. So that's a challenge. But as engineers, we are definitely up for the challenges, and we'll find solutions to accommodate whoever is needing whatever they are needing in this domain.
Now, and what about the standardization? You mentioned, obviously, we need to go through the standardization. 3GPP is working on this, and there's a lot of research going on. Do you expect it to be polarized, or is the industry converging nicely on, on new standards?
I mean, there is always some, glitches here and there. However, when you look into how 3G panned out, and 4G similarly, I personally don't see much of a problem converging on 5G, domain solutions. But 5G is not just a single, concept that fits everything. 5G has many facets. We're talking about low latency applications. and they are considered under tactile internet, then we are talking about high throughput applications and many other aspects. Even the IoT concepts is panning out as part of 5G. So I mean, the 5G is much greater than before compared to 4G and 3G, obviously. But we definitely will have a consensus.
Yeah, right. And as you say, IoT is going to, it's both a driver to 5G and also benefits from it. So you need to have lower latency for some applications and things like that. And so how important do you think that IoT is for a driver for densification? Because obviously you need more capacity. So how important is that going to be?
I mean, maybe I push a little bit technical here. When you look into the densification, like the normal densification, the concept of fiber drops for a dense network may become an issue with respect to the number of fiber drops in the system. How could you reduce this number of fiber drops? You can replace, let's say, instead of using fiber drops in every node, you can wirelessly, in a backhaul, you can connect these nodes. And you can obviously increase number of hops doing that. But the benefit is the cost, the total cost on the deployment. And when you look into the backhaul network that you create, it will be a wireless backhaul. However, due to the nature of multiple hops that you introduce, there is latency problems that you have to solve. So from any standardization perspective, the standards really has to be cognizant about all these scenarios and find a common ground so that it empowers people to use their own applications and interpretations and create harmony.
Yeah. And as you said, you can use the same band because there's so much spectrum in the millimeter waves that you can use the same band for both backhaul and access, right?
Yes. One of the approach we take at InterDigital, the approach is you have this 2 gigahertz links available to you. And not always you do need the backhaul links utilizing these channels. So in our approach, we definitely look into joint access and backhaul concepts, and where we obviously deal with the interference management. You do have interference from the backhaul to the access, or from access to the backhaul. And on top of this, you have latency issues that you have to fix. So we look into the densification from a holistic perspective, and we enable the joint access backhaul, and we solve many problems coming with it.
Mm-hmm. So can you tell us something about how you manage interference, for instance?
Yeah, like one simple example that I can highlight. If you have multiple channels that's available to you, between consecutive nodes, the neighboring nodes, you can definitely set these nodes utilizing a different channel and such that the consecutive neighbors will not see the signals, the impacted interference coming from the second-tier neighbors. Obviously, when you're doing this, you have to be very careful about your system performance, the radio performance, and the leakage that may come from other channels. So this is a simple example. Mm-hmm. And also, another example that I can provide is that based upon the directionality that you have, you would know how would you create a routing setup. And you can even create different directions. And instead of going through a hop directly, you can use multiple hops to convey your information so that you don't interfere. Mm-hmm. So this is basically one link active, affecting the other link is no longer be affecting the other link if you start playing with the directions.
Right. So there's but then if you have multi-hops, and latency might become more of an issue, and latency is going to become much more important. So you need not only capacity but low latency to get a good quality of experience.
Exactly.
And 5G, that's going to be a major challenge. How are you dealing with that, with the issue of just lowering the latency in a major way?
We actually, one simple example again I can highlight. And we do have many other ways of solving this problem. Now, say you have multi-hop systems, and you are receiving packets. Normally, what you do is you absorb all the packet, you receive everything in that packet, and then start forwarding. So if the packet is causing you 10 units of delay, and now you have to wait for 10 units, and then start forwarding that same packet another 10 units to the next hop. But what you do, you create, let's say, much smaller units within that packet, and start sending these small units. And without waiting the entire 10 units coming in, now let's say every 1 unit you started transmitting everything. So you immediately increase or reduce your latency from this angle. This is a simple example that I can highlight. But at InterDigital, we do look at every angle and what is it that we can do, and how the quality of service is always kept.
Yeah. And I guess that there are different ways to address this issue, because the latency is really becoming so important. But also, in addition, and I guess this is sort of like speaking to the increased complexity of the RAN, so there is much more work that we all need to do in order to make sure that the performance is high. It's the fact that inevitably, as you move to 5G, you're moving on in an environment where there are multiple wireless interfaces, legacy interfaces that are often used for coverage or capacity, or so you need to integrate them all. What's your view on what's the best way to go about it?
I definitely see the legacy devices as integral part of moving forward. We cannot just forget about the legacy devices and the legacy infrastructure and then start building completely brand new 5G infrastructure. So we need to develop technologies that would take advantage of existing infrastructure as the legacy infrastructure. And as well as with the opportunities, the bandwidth, the latency, and such from the 5G domain, we should take advantage of it. Let's say when you look into the 5G domain, the systems are heavily populated, and very highly directional beams are utilized. But you cannot have coverage in every corner. Even your hand movements, gestures, or anything on your handset will completely, destroy your link. Your connectivity could be removed. So what are you going to do if that's the case? So your system has to be adaptive enough to go back to the legacy and start using the legacy. So wherever it makes sense, we should look into the solutions that aggregates both the 5G and the legacy systems.
Yeah. So basically, 5G has 5G, 4G, 3G. They need to be integrated tightly so that you can have devices swapping back and forth between among interfaces. And I guess Wi-Fi is part of the picture too, right?
It is always part of the picture. As a matter of fact, Wi-Fi is much faster when it comes to 5G domain. Because, from the 3GPP perspective, when you look at the cellular domain, the evolution of cellular domain, the industry is much larger than Wi-Fi industry. So it takes a little bit longer time to really converge. But in the Wi-Fi domain, the focus is there. And the problems are not that immense compared to the cellular domain. So things are moving faster in the Wi-Fi domain. The Wi-Fi will always have its own place. And from a company perspective, again, we do have, resources looking into, both directions.
Yeah, from mobile operators, what is that you're hearing? Because sometimes you talk to them, when I talk to them about like higher frequencies, they're still a little bit nervous because they're much more familiar to, to the lower frequencies where they have full control, fully licensed, good, penetration, good RF. And then if as they move to higher frequencies, the regulation is different, coverage is different. What are you hearing from them?
I mean, let me, state this. There is no escape creating solutions for millimeter wave or for, high frequency channels. So when you look into the overall industry is pushing for that. And we definitely see the operators would take advantage of that as well. Mm-hmm. Even today, we talk about the operators are embracing, Wi-Fi and connecting with Wi-Fi, and we do see a lot of ads that's merging LTE and Wi-Fi systems. Moving forward, the anticipation is that some of the bands in the millimeter wave could be licensed, could be semi-licensed, and some of the band, like 60 gigahertz band, is the ISM band that's not licensed, that's unlicensed. But from an operator perspective, it is best if you can really take advantage of what is out there. From that angle, the operators, should be more adamant about creating solutions. And when you look into the applications with 4G, some of the applications we didn't even know that would come. When 4G enabled, then these applications pop up. With 5G, what we have is tremendously large bandwidth, very fast network, and all these capabilities. There will be a ton of new applications that would be mind-boggling would come up, and we will see.
Yeah. It will be interesting to see, and I think there's a lot of work ahead. And if you look at the next 5 years, what are you guys focusing mostly on? I mean, obviously 5G is the main focus, but can you tell us a little bit more specifically what is it you're working on?
For the densification purposes, we will continue looking into the solution space and looking into the challenging problems. And I would definitely see InterDigital providing solutions and shaping up the industry and having contributions to the standardization and the product domain as well. And this would not only for 5G, but what would come after 5G that we would be focusing on.
6G.
6G, hopefully. We don't know the definition yet, but possible.
In due time, it will come. Yeah. Okay. Alpaslan, thank you so much for sharing your thoughts with us today.
Thank you for having the opportunity.
So this was a conversation it is part of the report on densification and the evolution of the RAN by Senza Fili and RCR Wireless News that you can download from our websites. Thank you very much for attending, and have a good continuation of your day.